I've got an object. I've got a body. It has a known mass. I know how fast it's going when it starts off and where it starts off. Now here's an interesting thing. This is why I had to be a bit vague with this language here, okay? Resistance is proportional to, now this bit here will change, okay? I'll give you a classic example. When it comes to water, resistance through water is roughly proportional to speed, full stop, okay? But depending on the medium that you're going through, sometimes the resistance will be proportional not to the speed, but to the square of the speed, or to other things. In our case, we're really not going to see anything further than v squared, okay? You either be proportional to velocity or to the square of the velocity, but you need to watch out for that. That factors in, okay? Now, in this case, what we're going to try and work toward is an equation for the velocity in terms of displacement where I am, okay? So, you look at this, have a think, where might you begin? It might help if you have a think carefully in terms of the language that you already know and the pronumerals you already know about what information you have and where you're trying to go. Okay? So you have an m, right? You have a particular value of v, right? Now you have a resistance. You have a resistance. Now when it comes to all of the different quantities that you know, what is resistance about? What is it describing? And the answer is it's a force, right? So I know something about a force here, right? So being that, I'm going to go to velocity. I know a force, I know something about the force, and I know a mass. This is going to feed pretty nicely into that place we seem to start a lot, which is F equals ma. So there's where I'm going to begin. The moral of the story is if you never know what to do, you got no clues, just start there and you might get something useful. Okay. So here's what I've got. Resistance is proportional to the square of the speed. Now let me write this as an equation, okay? The way that I would say this formally is that F is proportional to, that's, it's not an alpha, it looks a lot like an alpha, but it's not. If you write an alpha, no one will complain. But F is proportional to the square of the speed. So that's v squared. Okay. So if something's proportional to something else, right, then what distinguishes them is a constant of some kind. Okay? It's like, oh, I'm always twice as big, or I'm always half the size, or I'm always, you get the idea. So I don't know what k is, but it doesn't matter. Okay? So therefore what I'm going to put in here is kv squared. Now, hold on a second. I'm going to pause before I go any further. Okay? Forces have direction, don't they? Okay? So even though this is a statement about magnitude, right? This statement in here doesn't make any comment about which way that magnitude is facing, right? Which way do you think it should face? Now, I want it to be, because it's resistance, right? I want it to be opposing the direction that the motion is in. Now, there's no definition at all, really, about what's positive and what's negative, but it sort of makes sense to just call whichever direction you're going in positive, okay? So we'll call that the positive direction, which means that this really should be minus kv squared. It's going to have that effect of reducing it. Okay, good. I know what the mass is. 5, and then I've got acceleration. Okay, excellent. So now I've got a starting point, I've stuck some stuff in. Where shall I go from here? Where am I trying to go to? I want to get to v as a function of x, right? So that gives you a big clue as to how you should rewrite acceleration. You've got a couple of different choices. Okay, what are they? You could go, well let's get acceleration on its own first. So I've got minus k on 5v squared, okay? You could go v dv dx, okay? Now that's a great candidate in this particular case because you've got a v over here and you've got v's here as well. So you can cancel things and make things even simpler, right? K on 5v squared, right? So I'm going to divide through by v, which means that at this point now we are implying a restriction, namely velocity can't be 0. Okay? Now, have a look at this. Where do we go from here? Okay, these are always the points at which you need to stop and think. I have a problem, right? I want to get to velocity, right? And so it seems like a good thing to have a dv up there, because when I integrate, I'll get a v on that side. The problem with this, though, is that this is differentiating with respect to x, right? But I don't have any x variables over here. So I can't really integrate this right-hand side with respect to x. So what should I do? I should flip, right? If I make it with respect to v, I'll flip that, I'll flip this side as well. So that looks like it's going to be minus 5 over k, 1 over v. Okay. So far so good? So now that I have it all in terms of v, I can actually integrate. You're going to integrate everything, okay, with respect to, you'll get an x over there, and then that minus 5 over k is just a constant. I probably should have mentioned that here, shouldn't I? Okay? So therefore, you have your minus 5 over k here, your 1 over v dv there, right? What's the integral? It's log, good. Now it's indefinite, so I have some constant flying around. Okay, now, this is not really what I want, is it? This is not what I want. I'm after an equation for v in terms of x, and I've got an equation for x in terms of v, but that's okay. All I need to do is rearrange this and get the inverse and I'll be fine, okay? What do I do at this point? Got to get rid of that constant, okay? I can use this initial condition, right? Because initial doesn't just mean t equals 0. I might as well just say, well, start at the origin, right? X equals 0, okay? So now I have some values. I have a v value, 8, and I have an x value that I can put into this, okay? So when, got that, okay. Let's sub it all in. Okay, there you go. So now I can bring this back into my displacement equation, x equals, and it looks a bit gross with all of these log terms hanging around, but it's not so bad, right? What can I do? I've got heaps of log laws I can use here, right? Now, have a look at this thing. Watch out for that minus sign. What should I do? Maybe I'll take out a factor of 5 on k first, right? And then this is positive, this is negative. So I have log 8 minus log v. Is that right? Does that look okay? Now, here's the thing. That's going to end up with, when I put these together with my log laws, right? When you subtract, you're going to have 8 over v. That's kind of a pain, but because I want to end up with v. Okay? So instead of that, what I'm going to do is, I might just slap this minus sign here at the front, and that will reverse the order of my logs. Okay, so it's going to become this, v over 8. Okay, so this is minus 5 over k, log, and here's my log law in that. Okay. So now, I'm just a couple of steps away. I need to get that log by itself, so I'll kick these guys over the other side. Looks to me like I'll get minus kx on 5. Okay, so far so good. Almost done. How do I rewrite this thing? V on 8 equals e to the minus kx on 5. One last step to get to what I'm after. V equals multiply through. And you're like, yowza, it's exponential decay. Oh wait, of course it's exponential decay. Because what does exponential decay mean? It means something's reducing, in this case it's velocity. Something is slowing down, right? But as you slow down, the rate at which you slow down, it gets smaller, right? Of course it does, because it's proportional to the square of the speed. So as you get slower and slower and slower, the resistance also reduces, right? So you're never going to get to, at least in this situation, you're never going to stop fully, okay? Because this thing is asymptotic at 0, okay?